What are the limits of silicon-based chips? How much smaller can we go? New applications demand more specialized, powerful, and efficient chips. So, researchers and academics are reaching for new solutions, new materials, technologies, and tools like AI. And what's complicating matters even more is a global trend towards reshoring chip design and manufacturing. According to a recent Deloitte report, by 2030, the United States and Europe are planning to collectively regain 50% of the chip manufacturing capacity, which over the last 3 decades has gotten increasingly concentrated in East Asia. That means more competition for scarce talent. So, how do schools in Taiwan and the Netherlands prepare the students of today for the chip tech of tomorrow? And what should you be looking at if you want to get into semiconductors in 2025? To give us some answers, we have from Eindhoven University of Technology in the Netherlands, Aida Todri-Sanial, who is a professor in the Electronic Engineering Department. And from Hsinchu in Taiwan, we have Professor Kuan-Neng Chen, who is the Dean of the International College of Semiconductor Technology at National Yang-Ming Jiao-Tung University in Hsinchu. Kuan-Neng, I'm going to start with you. So as I said earlier, we can see this trend in the industry, which is trying to diversify production and manufacturing, spread it around the world. But one of Taiwan's advantages, as you yourself pointed out, is that the entire production chain, or almost the entire chain, is located here in Taiwan. Do you think the world is going to lose or gain with this trend of reshoring?
I believe that the world is going to begin. Of course, this is also the advantage because when the new materials or when the new devices or new product is kind of like developed, so it's a very efficient and easy way to do everything localized in Taiwan. They can save a lot of money and they will be making the things more efficient, especially that for the communication and for the development cycle, the time, especially it's going to be across the different kind of not only about the companies, but also we are talking about different kind of field of the setup, from IC design to chip fabrication to the packaging. So of course, crossing together is much easier comparing to just spread out to the world. I do see the benefit is kind of like it's more efficient, and the cycle time is going to be fast, and it's going to be more. I will believe that the total cost is going to be lower.
Well, Aida, as a researcher, are you looking forward to more resources being allocated to Europe, or are you concerned about the increased competition for talent?
Indeed, there will be a race for talent, but I think if we start to at least raise awareness, make them conscious about all the various choices from the get-go, so there is opportunities for them to join, and there could be a lot of them working more mainly on the fundamentals, on the materials and devices, maybe some of them on IC, others more on the mechatronics and equipment. So I think there is opportunities. There are so many. I think we also, as educators, there has to be a little bit more of this reaching out to very young students, high school I mentioned earlier, but even early bachelor, when they're making their choices, to be able to allow them to, maybe they will find their way somewhere in this semicon field. But I think we need to be a little bit more out there, reaching out and making them aware how exciting and full opportunities are to work in these areas.
Well, geopolitical changes are just one side of this situation. Another side, which has always been true for semiconductors, is the technological progress. So, how do you teach a field that can dramatically change in a matter of months? Once again, Professor Jiun-Haw from National Taiwan University's Global Undergraduate Program in Semiconductors gives us his take.
So for the undergraduate program, we need to teach students something unchanged for the 10 year, 20 year, 30 year. So that is science. Science doesn't change. So if you know the science and you know the limitation of the technology, then if this technology, for example, the electrical interconnect, there's a bottleneck, so they can calculate, from the science, it's very difficult, maybe possible, but difficult. So maybe at this moment we can change to the optical interconnect. So photonics way, silicon photonics. So I want to equip the student, they have the ability to do this kind of the mindset. But if you go to the technology, that change very fast. The other thing is, for example, material. For the material, we want to down to the 7 nanometer to 5 nanometer to 3 nanometer to 2 nanometer, then 1.8, then 1.4. Then students need to know what's the limitation in the future. Then that is one thing. What is the bottleneck? Then what is the solution? So that's how we train the engineer. We know one day that will come. Then what's the solution?
So Kuan-Neng, how do you prepare your students for this future, this unknowable future where technologies might shift dramatically in a matter of months?
Yes, I totally agree with what Professor Lee just mentioned, that I believe that the science is very important and the fundamental knowledge is the critical point. If you know that how to do the problem solving, how to solve the problems, and you have the skills to see what's going to happen, and if you have the very good scope to see for the future, I think that will be certainly help. So like, for example, like in ICST, we encourage our students to become a T-shaped students, which means that in addition to your personal the expertise or your research field, you also need to have a broad mind to figure it out that what kind of background knowledge you should have. As like the Professor Lee just mentioned that right now, for example, like semiconductors, we are looking forward to for the future is from the electrical connection to the optical connections. So that's why we see more and more requests on the optical things. For example, like a CPO called package optics, which is exactly try to making sure that for the future electronic systems, we will have enough speed. But for that, we need to have not only the electrical engineering, the knowledge, but as well as from the photonics or from the optical knowledge. So I believe that for the future, we may need to have more and more, for the students, they need to have more and more interdisciplinary, this kind of like the skills.
Well, photonics is one exciting thing coming up in the field of semiconductors. Another that a lot of people are talking about is AI, and not only meeting the demand for AI chips, but also using the AI in the design and manufacturing process. Aida, how is that changing the curriculum, the semiconductor curriculum?
Mm-hmm. So yeah, tools like AI tools are there. I think it's interesting that they can use them to explore, but the principles endure. I think it was mentioned also earlier that we try to teach them solid critical analytical skills from the device physics, from the circuit design, also from how you'd actually analyze it. So we really are trying to teach them the fundamentals that they can critically think and also double check if they're using any of these AI tools. So I think it's important to see that in the end, we want engineers to be able to be problem solvers, right? So it's about not only the results that they get out, but it's also about how, the why and the how. So I think these are critical skills that we are very much focusing on. It's important also to mention that tools will change, right? So there are some optimization tools, so there are some other tools that they can use to explore. But we want them to also critically think, all right, what does this results? So it's not they're just using input data in and out. Be able to also think a little bit more, what is behind? Can they critically think, what does this system perform? What does this circuit does? So we're also trying to instill very much the system thinking capability. So building from basic blocks, from the device to circuit to the architecture level, looking at it from a system level. You mentioned earlier electronics, photonics. Heterogeneous integration is key in our university going forward. So we really need people that are also multidisciplinary, looking at multi-scale, multi-domain. Why? Because the future chips also are going in that way. For example, chiplets, advanced packaging. All of this also requires system thinking, require students that have some capability from electronics, from photonics, from device physics, bringing it all together. So I think what we are focusing on is, regardless of the tools, the fundamentals or the principles endure. And these are things that we can really, I think, make a difference for them going forward. So they are not necessarily taking AI for granted, but being the engineers, the problem solvers going forward.
Well, Kuan-Neng, I want to close out the discussion with a look towards the future. So we mentioned photonics, we mentioned AI. From your perspective, as someone who has been in the field for a long time, what are the biggest challenges coming our way in the coming months and years?
If we talk about for the AI, we have the certain limitations need to solve. For example, like the thermal issues or like the mechanical issues. And a lot of them is not only related to the device itself, but also it's coming from the system level itself. As like Professor Aida just mentioned, that heterogeneous integration becomes very important because it's kind of like to integrate different type of building blocks and to make it become a big system and big product. I personally have been working on this for years, and we know that how difficult it to do. So for the future, especially as just what we all of us just all agree that is for the future, I think that the problem solving skill is very important. I think also the critical thinking, including the creative thinking, is also very important when the task is coming and how to do it different way, and also open-minded to work with others, other colleagues or other college, or working internationally, working with the companies or working with someone you don't know, but you know he or she can help. I think that will help the students, and we believe that for the future, it's going to be like a collaboration and a teamwork, especially for the semiconductors.
Well, Aida, I'm curious about your opinion from a more European perspective. Challenges, not only technical challenges and technological challenges, but also the geopolitical or even financial challenges that Europe is going to face trying to reshore and build up its industry, including research and education.
What is interesting about our model is that this exchange, we have Erasmus programs, we have a lot of master level or even undergraduate level exchange programs, which allows them to get the best of all the various universities. So this has been something very unique to our academic system. Now, going forward for the semicon, the challenges we are facing is we need more people getting into the field. We need more of this curiosity-driven, so they can also be part, they can contribute in every part of the semicon area, but we want this kind of new thinking. Why? Because the problems that we are facing also require new ways of thinking from the materials, right? But also being part, for example, even from the integration, from new chip design, we have an energy problem. We have supply chain problems. So I think we also need to kind of rethink the fundamentals, and that's where our universities, and also we are very interestingly located, for example, for TU Eindhoven, in this research triangle between Leuven, Eindhoven, Aachen, where all of this new type of devices, new type of materials, new ways of computing and sensing, so bringing it all together into this intelligent or smart systems for edge or not only. This is a very, I think, very exciting areas, and also it's happening here in EU. So indeed, we do have problems financially. Our geopolitics are not necessarily very favorable at the moment, but still there are national programs. There are some European programs that are very much trying to boost these topics from both education and also research. So I think despite the challenges, I think there is quite a lot of very interesting dynamics and momentum going on in EU at this moment.
That is great to hear. Before we finish today, from me, an enthusiast, since I have two researchers here, as a reward for other enthusiasts who made it all the way to the end of the show, I want to know what each one of you is the most excited for, one technology that is coming up or that is on the brink that you are keeping your eye on. Kuan-Neng, what would that one technology be for you?
Okay, so for me, I would choose the 3D IC, which is the heterogeneous integration or advanced packaging, or we call it heterogeneous integration. I've been working on this since the year of 2000. So since the past 25 years, I'm seeing that it's coming gradually booming up. Finally, in the past 3 to 5 years, it looks like all the technologies, all the devices, all the systems requires advanced packaging. And it's more exciting things is that, this technology is more like building blocks. So everyone can be very creative to try to build up, try to stack different kind of things all together, so to make it a new systems, a new semiconductor devices, or the new product for the futures, even for the automotive or for the health devices. All these kind of things becomes very creative. So it's kind of like create a new scope and a new field for everyone, especially for the semiconductors.
I love exciting things. Aida, what's your one thing that you're looking forward to in semiconductors?
I have so many. So it's difficult to choose, but I will focus maybe on the heterogeneous integration, bringing electronics and photonics, merging the best of both worlds. We have energy efficiency problem. We need to process data more efficiently at the edge. We need also sensing. We need the antennas. We need the memory very close by. So maybe 3D, but heterogeneous hybrid integration, bringing it all together. And photonics is going to play a key role going forward. And there are so many, even at the interfaces of these domains. So I really am also very much in favor of the interesting partnerships, collaborations, but also research topics that will come from heterogeneous integration.
Thank you.
So we have the same. Yeah, we have the same conclusion, right?
Well, everyone who is enthusiastic about future technology seems to be focusing on similar things. That's great. That means people are working on it. Thank you very much to both my experts today.